Now imagine once again that we have 8 cables and there is current on every cable. So current on the first cable, second one, and so forth and so on. Each cable has current. That means that this value is 128, 64, 32, and so forth. If you add all those values together, so 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get a value of 255. Thus, 8 binary ones equals 255 in decimal. That's because each logical cable is set on. In other words, it has a value of 1. And this value, for example, represents 2 to the power of 5, which equals 32 in decimal. So adding all of those values together gives you a value of 255 in decimal. So let's demonstrate this using a Windows calculator. So in this example, I'm going to go to the calculator and change it to programmer. This allows me to see both decimal and binary values. So 255 in decimal is equivalent to 8 binary ones, or once again, 8 binary ones is equivalent to 255 in decimal. 255 in decimal is equivalent to 8 binary ones. So here's another example. What is the binary equivalent of 1 in decimal? So using our table, the decimal value is 1. That means that these values are all turned off. In other words, the binary equivalent is 0 for the first 7 values, but the last value is turned on. So 1 in decimal is equivalent to 7 binary zeros followed by binary 1. Once again, using our Windows calculator, 1 in decimal is equivalent to 1 in binary. But because we're using this mainly with IP addressing, you'll tend to write it as follows. The Windows calculator removes the leading zeros, so 1 in decimal is equivalent to 1 in binary. In this example, what is the equivalent binary value of 192 in decimal? So using our table, 192 is equivalent to 128 plus 64, which implies that the first bit is on and the second bit is on, but the remaining bits are set to 0. 128 plus 64 equates to 192, thus 1 followed by 6 binary zeros is equivalent to 192 in decimal. Using our Windows calculator once again, 192 in decimal equals 1 followed by 6 zeros in binary, which is once again the equivalent of 192 in decimal. Here's another example. What is the binary equivalent of 253 in decimal? Now 253 in decimal is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 1. And once again, that gives you 253. So 128 means the first or most significant bit is set on. 64 implies the second bit is on. 32 means that the third bit is on. 16 means the fourth bit is on. 8 means the fifth bit is on. 4 means the sixth bit is on. And the 1 means that the last bit or least significant bit is on. 2 is set off in this example. So 253 in decimal is equal to 6 binary ones followed by binary 0 followed by binary 1. So 253 equals 6 binary ones followed by 0 followed by 1. So I'm hoping at this point you have a good understanding on how to convert decimal to binary and back again. There are many tricks with regards to binary that can allow you to speed up the calculations. One example would be that 255 less 2 gives you 253. In other words, this value is set off, which allows you to work out that 255 looks like this, but that bit is set off, so 253 looks like this.